Hi there and welcome to the screencast for Workshop 5. Today we're going to be looking at the dplyr library for data wrangling. And we're going to be using a new data set which is the count of students of each gender, ethnic group and year level for school students in New Zealand from last year, 2021. And I got it from this website here. If you wish to go and get the raw data, there's a lot more than what we're just dealing with here. We've got years going back quite a bit further than just 2021. So we're going to start by reading the data in. It's reasonably large. It may take a little while. You can see we've got 103,666 rows. And you can see that for each row here, we have the count of students in the combination of the school, gender, ethnic group, and year level. Okay, one thing you'll note is I've added message equals false here to the header in the R code chunk, and that just guarantees that I don't get the normal output from read CSV and library tidyverse. So normally when you you spit out library tidyverse, you get a bunch of output telling you which packages are loaded and so on, and you also tend to get messages from read CSV telling you how it's interpreted each column. And so to suppress that, I've just added message equals false, which turns off the messages. We'll still get errors, so errors will still show up, but messages and warnings will also still show up, but messages won't. Okay, so we're going to start by making sure we can knit this document successfully before we make changes, just to make sure that any changes we make that break the knitting are then our fault. So let's just check that. Okay, it seems to have rendered correctly, and we can see in particular that this code chunk here doesn't have the usual output from library tidyverse and from read CSV. Okay, right. So we're going to work through this and introduce ourselves to dplyr. So dplyr is essentially a package that allows us to do data manipulation, and essentially there are 5 verbs, which are filter, the one we'll look at first, which is for choosing rows. There's select for choosing columns. There's arrange for changing the order of the rows, so sorting the rows. There is summarize for collapsing the rows down to a single row, so computing a summary statistic such as a mean or a median and so on. And then there's mutate for creating new columns in our data based off existing ones. And then all of those can be combined with the group by verb, which we'll look at tomorrow in Workshop 6. Okay, so we're going to start off with filter. So let's read this and see what this does. So we're filtering our role such that the ethnic group is equal to Māori. So you can see here that all rows here, all 29,304 rows are going to have ethnic group set to Māori. Notice that we use the double equals here for is equal to. That compares to a single equals for assign. So if I try that, then I'm going to get an error message. And in this case, it's smart enough to tell us what it is. So did we mean ethnic group equals, double equals Māori? And we did, of course, mean that. Okay, we can combine conditions. So this is a logical expression that when it's satisfied, the row will be returned, and when it's not satisfied, the row won't be returned. And we can combine things together. So for example, this first one here, that first line of code is going to return everything in the row where the ethnic group is Māori and the gender is equal to female. So you can see here that all of the 14,575 rows are going to have gender female and ethnic group Māori. If we want one or the other, then we use a vertical bar. So comma is used for and vertical bar here is used for or. So if I run the or one, I obviously get many more rows because one or the other conditions are satisfied, then a row will be included, so therefore the number of rows must of course be larger, or at least the same. So this is ethnic group is Māori, or the gender is female. So you can see here that we've got a bunch where the gender is female, a bunch where the ethnic group is Māori but the gender is not female, and then we've got some of course where both are satisfied. So the or here is not an exclusive or, it's a normal, regular conversation or. So if I say ethnic group is Māori or gender is female, what I'm meaning there is that as long as one of those criteria is satisfied, or at least one of those criteria are satisfied, then it will be included. A couple of extra helpers. So commonly it's quite common, particularly when you have grouping variables like this, that you want to select out rows that satisfy two criteria for the same grouping variable. So for example, this command here is pulling out all the rows where the level is year 1 or the level is year 2. And you can see that expanding this to year 3 as well, it soon gets quite a bit of repetitive typing, right? So that would give me year 3 as well. So the in operator is quite handy for this. So that simplifies things, and that I can just put the conditions that I require in a vector. So concatenate together with the C function, and then just test whether the level is in that set. Okay, so that will of course return the same thing. So you can see I get 22,524 from the first one and 22,524 from the second. So let's have a go at ourselves. So I recommend you just add a new R code block and do the filtering. So we're going to filter our role data such that we want Queen Elizabeth College, so that'll be the school. I'll copy and paste that, so that's going to be the school. It's going to be equal to Queen Elizabeth College. Make sure you do put it in quotes because that's a label. And the student's going to be in year level 9. So there we go. Okay, so you can see we just have 5 rows, so we don't have all possible combinations here. So in total it looks as though we have 50, 60, 66 students. Okay. Find all rows where there are more than 100 year 9 Asian students. So again, we're going to filter our role data such that, what do we need? Let's put all our criteria in. We want our ethnic group to be equal to, right, that's the name of the column, to be equal to Asian. Right, so that'll give me just the rows where the ethnic group is Asian, but we've also got year 9, so we want the level to be equal to year 9. Okay, so now we've got 602 rows, and we want the number of students to be at least 100. More than 100, so I guess it's greater than, isn't it? Not greater than or equal to. So there you go there. So there are 10 rows which satisfy this criteria. So Auckland Grammar has more than 100 males, Asian students in year 9, and so on. Now, this isn't capturing the number, this isn't capturing the requirement that the number of students in the Asian ethnic group in each school adds up to more than 100, because we haven't specified the male or female. So you can see that some of them, like Rangitoto, right, have both over 100 males and over 100 female Asian students in year 9. But you can imagine there's probably some schools here that haven't been included, because while the number of male students, male Asian students in year 9 might be less than 100, the number of female Asian students in year 9 might be less than 100, combined together, when you add them together, perhaps it might be more than 100. So that would be we'd need some different code in order to pull that off, and we'll learn about how to do that next time. So this is just single rows, so we can't combine rows in the filter statement. Okay, and the last one, find all rows where the school name starts with the letter G. Okay, so we could just go filter. So we need the school name starting with the letter G, so we could try school greater than G. Okay, so you can see here that we're starting at Galatea School and so on. We'll eventually get another one and so on and so forth. But if we go far enough ahead, then of course we're going to eventually, well, in the first 1,000 we're still in the G's, but you can see we've got 84,000 rows, so clearly we don't have just schools starting with G here. So we'd have to restrict it, right? We only want school starting with G, so we'd also require that the school is less than H. Okay, and so now we've got 3,364 schools. Okay, so school starts with G, must be less than H. Okay, the other way to do that, which is perhaps more readable, is to use the str_starts function. So the str_starts function takes our string, which in this case is going to be school, and it takes a pattern. So if I go str_start school G, then it will immediately get me my 3,364 rows. Okay, now technically the thing that you can put in here could be a regular expression, but a fixed string will work as well, just as well. Okay, you don't need the dot star for the regular expression. If you don't know what I mean by that, don't worry, it's not important. Okay, so that's how we could find all schools starting with G. So that's the filter. It's for choosing specific rows that satisfy some criteria. The next verb we're going to look at is arrange. So arrange is obviously to change the order of the rows. So this is for sorting the output. So let's have a look at what these two statements here are doing. So the first one is arranging the row first by gender. So females will come before males because female is alphabetically before male, right? F before M. Then within gender it will organise by ethnic group. So we'll have Asian first, obviously, because it starts with A. And then within the ethnic group, it will arrange by year level. Okay. The second one is arranging by role, descending the number of students. So if we go across here, we can see that the first row here is the one that has the most students. And if we go back and have a look, this is Te Ahu Aotekura Pounamu, which is the correspondence college, which kind of makes sense for the most students. Okay, so let's try this. Arrange the roles by the number of students. Well, that's just what we did up here, isn't it? Except instead of descending, we're going to go ascending. So we'll just remove the descending function. Done. So you can see here that there's a bunch of rows that have only one student in them. So there's only one male Māori in year 10 and A1 student limited. Okay. Right, let's have a look at another one. Find all rows where the ethnicity is Pacific, arranging them by decreasing number of students. Okay, so this is a two-step process, right? We've got a condition here, ethnicity is Pacific, and then we've got a sorting order, decreasing number of students. So we're going to do it in two steps. So the first one is we're going to find the Pacific students. Right, that's going to be a filter. And we're going to say ethnicity, ethnic group is equal to Pacific. Then once we've got our Pacific students, so we can see here we've got a new variable here, Pacific students, that just has the ethnic group equal to Pacific. Right. Once we've got those, we're going to sort them. So we're going to say arrange the Pacific students by decreasing number of students. So there you go there. So you can see that the row with the most Pacific students is Auckland Girls Grammar, which has 171 Pacific females in year 9. Okay. So this is a two-step process where we first filter and then arrange. Okay, we've got another example here. Which school has the highest number of international fee-paying students at year 13? So we've got a sorting criteria here with the highest number, and then we've also got a restriction on international fee-paying. So international fee-paying is an option for ethnic group, and also year 13. So again, we're going to say internationals. So we're going to do a filter where we grab the role data and we restrict it to ethnic group equals international fee paying, and the year level is year 13. Okay, so now you can see we have the internationals data set with 309 observations, all with international fee paying and year 13. And now we want to arrange this by highest number. So we want to arrange this by descending. So we can do it in here. Just by clicking the students column, we can see that the answer is UP International College of New Zealand. So in code, we could take our internationals data and arrange it by descending numbers of students. Okay, and we'll get the same answer there. Okay, so UP International College of New Zealand has 57 male students. Now again, I want to emphasize that we haven't restricted the gender, so there'll be some schools here. So to answer this question, we haven't actually answered this question, I don't think. Oh, we probably have actually, because you can see that the International College of New Zealand is first for males and second for females, and so if you combine those two numbers, we're definitely going to have the highest, right? So you've got 57 and 33. The next closest is going to be Westlake Girls. In fact, they're a separate college, so we're done. Okay, but technically our code doesn't answer the question which school. Instead, it is which school has the highest number of international fee-paying students at year 13 of any particular gender. Okay, we haven't specified the gender here, and that's why we've got 2 rows for UP International College, and we'd have 2 rows for any school that is co-ed. Okay, now I'm just going to close this down and bring it up again, just because I don't like the fact that we had some weird thing down the bottom here. That's a Linux issue with RStudio that's been around for a long time. They still haven't fixed. So now notice that what we've done here is a 2-step process. So we've done it twice. We first created a Pacific students data set so that we could then arrange it, and down here we created this internationals data set so that we could arrange it. But these data sets are only really there so that we can then perform the next command. We don't actually really need them to be stored. We don't really need to click on them and view them again. We just sort of had them as a stepping stone to get the answer that we wanted to in the end. So for example, we could have done things like this. That last question, instead of doing a single filter with both conditions, we could have broken it down into, first find the internationals, then find the internationals that have year 13, and then arrange them, right? That would have got the same answer. But again, this internationals and this year 13 internationals data frames are just there so that we can then go on and get the right answer in the end. They're only really temporary. So we could just get rid of them by writing code like this. Now this is extremely unreadable code. We won't be writing code like this because you have to read it inside out, right? We actually start here. Here's our original data, and our first thing we do to it is we filter it. And then the answer from that filter gets put into the second filter to filter out the year 13s. And then the answer from that second filter gets put into the arrange function to arrange descending by the number of students. So instead, we're going to use the pipe operator. So the pipe operator is inserted by using Control-Shift-M or Command-Shift-M if you're on a Mac. And that produces this character here. Now, by default, you may see that it produces this one. Okay, so % greater than %. That's a different version of the pipe, different pipe operator that comes with the tidyverse. You don't actually have to use that. So I recommend you go into Tools, global options, and under code you turn on this one here. So use the native pipe operator. There's the requires R4.1 plus. Most of you will be on R4.2, so that won't be a problem. So make sure there's a checkbox here. Okay. So then when you Control Shift Enter, you get an M. Right. So what the pipe does is it allows you to take some output and feed it into the next function. So here we take our roll data, so that's the original data frame with our 103,666 rows. We then feed it into the filter to filter out the ethnic group as international fee paying. We then filter the answer to that into another filter to pull down our year 13s, and then we filter the answer to that into our range. So when you read this, you can read it from left to right, right? Take our roll data, filter such that the ethnic group is equal to international fee paying, filter that such that the year level is 13, and then arrange by descending number of students. Okay? So let's try doing one of the above ones by ourselves. So perhaps we'll take this one instead. So we'll put a new code chunk here. So there was our code that we had before. Remember, this was find the row with the greatest number of Pacific students. Right. So now we're going to take our roll data. We're going to pipe it into to filter out our Pacific students, filter down to our Pacific students, and then we're going to arrange it by the descending number of students. Okay, so there we go. So again, we get the exact same answers we did before. It's just much more readable in terms of the code, and this is what we'll be using from now on. Okay, so take the roll data, filter such as the ethnic group is Pacific, and then arrange by a descending number of students. Right, so we've figured out how to deal with different rows. We can filter out ones we don't want and just keep the ones we do with the filter command, and we can arrange them or change the order using arrange. We can do the same thing with columns. So the select command allows us to pick which columns we wish to keep based on their name or number. Okay, so let's have a look at these following statements. This first one, let's read it. Take the roll data and select the school, ethnic group and students columns. So we'll get the same information that we had from the whole data set. We've kept all the rows, but we've just picked out those three columns. Okay, so we've dropped the gender and level columns. What about the second one? Take the roll and select not the school, minus school, so don't include the school, and select the number column, changing it to students. So let's have a look and see what that does. So this is dropping the school column, and it's renaming the students column to number. Okay, so that drops the school column, renames students to numbers, a number. What about this one? So this one takes the roll data, it picks out the students and level columns, and then everything else. So the everything operator is a way just to pick all of the columns without having to type out their names. So what this has done is it's relocated the students and levels column to the left. Okay, and that's quite handy because sometimes you have hundreds of columns and you just want to pull one of them across to the left so that when you print things out you can see it. Okay, now because this is a common procedure, there's actually another function for that, which is relocate. So relocate the school and level automatically pulls those two out to the left. Sorry, we want students, don't we? Okay, so okay, so that's a common way to get that same thing done without having to use the everything statement. And you can see in the help for relocate that you've got before and after, so you can pull things to the right by specifying them after the right hand side and so on. So let's have a go. So this first one, rearrange the role data set so that students and level are first. Well, that's exactly what we've just done, isn't it? So we might just do it again. Okay. Rename the school column to name, keeping all the other columns. So we're going to select name equals school. Right, that'll just select the school column and name it name, but we want everything else now. So there we go. So we've picked out the school column and got everything else. Okay, the other way we could do it is, of course, we could just type everything out, right? That's what the everything operator is for, obviously, is for saving us having to type everything out. Okay, and because renaming is a very common thing to do, so in this case it wasn't too bad because we were naming the thing at the left. But what if you were naming the last one? You'd have to type out all the names of the other ones first so that you could then type the name of the last one and what you want to change it to. So there's a shortcut for this, which is the rename function. Okay, so rename always returns all of the columns, and it just renames the ones that you specify. Right, so this will give me the same answer, but now it's easy for me to rename this last column. Right, if I wanted to right, I've changed that last column while not having to remember what the name of the other ones are. So the rename function, just like the relocate function, is just a shortcut because often there are sort of common things that we want to do. So there's shortcuts for doing it. Okay, so that's how to move columns around. There's a bunch of other ones as well, but those are the main ones that we'll use. What about adding a new column? So the mutate verb is used for that. So mutate adds new variables using functions of existing columns or constants. So this first statement we can tell is saying role. So mutate. So take our role data and add a new column with mutate. The new column is called proportion, and it's equal to students divided by the sum of students. So what we're computing here is the proportion of all students that are contained in each row. So you can see this is 1.2 out of 1 million. Okay, because there's about 1 million students all up. The second statement, what's this one doing? Well, you'll notice that when I ran it, I didn't get any output because, of course, it's assigned the variable clean. So I've got this new data set clean. And if we have a look at this, then what's changed is that the level variable is now a number, rather than saying year 10 and year 11. And the reason that's important is that otherwise the level variable would sort wrong. So to demonstrate, let's filter. Let's take the role data and filter where the level is in year 1, year 2, and year 10. and we'll restrict it in other ways as well. We'll say that ethnic group is equal to Māori, and gender is female. Just so I don't get too many lines. What's my problem? So object ethnic group not found. That's because I spelt it wrong. So I should have used tab autocomplete there. There we go. Okay. Now we're going to arrange this by level. And you'll see that when I do, if I run through here, I get all of my year level 1s. And then after my year level 1s, which there'll be quite a few of, I think. Is there going to be too many? There's too many. Let's restrict it a bit more. Let's in fact just choose a single school is probably the better way to do it. So let's choose Shannon School. Why not? Okay. So you can see here, Shannon School doesn't go up to year level 10. Let's choose a different one that will. Maybe what we'll do instead is we'll say school starting with the letter G, like we did before. Then there's not too many of them. Perfect. 880 rows, so not too many, and I've arranged by level. So let's see what happens. So I've got all my year 1 schools, and then as I go further down the list, I suddenly have my year 10s. Right, so year 1, year 10s, and then as I go further and further down my list, all of a sudden I get my year 2s. Right, so when we arrange the original data roll by level, year 10 sorts after year 1 and before year 2. Reason is it's sorting alphabetically. Right, so the 0, so the 1 here sorts before the 2. Right, it doesn't know that this is 10, doesn't know that it should sort based on sort of an alphanumeric sorting. Okay, so that's what this is fixing. So what we're doing is we're taking the roll data and we're overwriting the level variable and we're converting it to a numeric. And we do that by taking the level variable and substringing it and then converting it to a number. So let's break that down. Okay, we will. So what we'll do first is we will just do the substring operator. Okay, you can see that here's the level variable and here's the new level variable. So the substring operator is just taking away the first 5 characters. It's starting with character 6. Okay, so R is 1 based, thus this is character 6. So you can see here that I just have 10, 11, 4, and so on. You can see it's still a character string though. So the next step is to convert it to numeric. So the as.numeric function can do that. So you can see that new level 2 is a double. So it's a numeric type, and it's now numbers, and so it will sort like a number will. Okay, so up here all we've done is we've done both statements at the same time. So we've taken the level, done a substring, and then as.numeric it. And we could in fact use the pipe for that as well. So we could have said we take the level, pipe it into substring 6, and then pipe that into as.numeric. Alright, and that will work as well. So now you can see that the levels are 10. This is perhaps a little bit more readable. Okay, so the new level is equal to our previous level, converted using substring 6 to pull out the 6th character onwards, and then converted to numeric. Okay. So we're going to use the clean data set from now on. Create a new column combining the ethnic group and gender using the paste command. Okay. So we're going to take our clean data set and we're going to mutate and creating a new column. So let's call it gender, and that's going to be paste our ethnic group and gender. Okay, so you can see here, if I make it a bit bigger perhaps, there we go. We've got this new column eth gender, which combines the ethnic group with the males. So I've got Māori males, European males, and so on. European females, and so on and so forth. Okay. Now suppose we want to redo this, but we want to also remove the old columns. So we perhaps we only want the combined column together for some reason. Then we would obviously take that previous code. And then what are we going to do? We're going to get rid of the other ones that we don't want, right? So we're going to select out the gender and ethnic group. Okay, so that's going to be okay. So this might be useful, for example, if you're constructing a table or something like that. Okay, what about this next one? Create a new variable age with the typical age of students in each year level. Year 1 students are typically 5 years old. Okay. So we're going to take a clean data set. So what we're going to do is we're going to take our level. Let's just actually rerun this clean up here, just so that I've got the same data set that you'll have, without that new level variable. There we go. So we're going to take our clean data set and we're going to use the level information to get the age. So the hint was that year 1 students are typically 5 years old, so to get from 1 to 5 we need to add 4. Okay, so this is the typical age of students in each year level. This is the age they start. You'll probably know that in year 13 most students will start age 17, but will tend to have a birthday sometime in the year, and so will leave age 18. Okay, so that might be the start age. Okay, so that's how we add newcomer. And the last one we're going to do is we're going to investigate using the unite function to do what we did in part 1 and part 2. So part 1 and part 2 were combining 2 columns, and because that's an operation that's done fairly regularly, there's a helper for that. Okay, and it's the unite function. So let's see how that works. So I'm just going to type unite, and then I'm just going to press F1 to get the help. And we see that this says unite multiple columns into one by pasting strings together. So here's the format. So the first argument's the data, which we'll be passing in with the pipe, and then we pass in the name of the new column as a string or symbol, so we can just type the name. The dot 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 are the columns to unite, so those are the various columns that we want, and then we can see that we've got a separator, and we can choose to remove them and so on. So what I'm going to do now is, because I don't know what the dot 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 means, I'm going to scroll down and have a look at the examples. So you can see this uses the previous pipe, but I'm just going to copy and paste this code just to see what happens. So let's put this down here. So I'm going to run that. So here's my data frame, and I'm going to unite. Okay, so I can see here that Z has been created by uniting the A and the X and the Y, and I haven't removed them. So you can see here that Z has just pasted these 2 columns together. Okay, so it seems as though what I want to do is I want to say my new column is going to be my eth gender, and the columns that I want to put in are going to be the ethnic group and the gender. So let's run that. And that's exactly what I want. So by default it's used a separator of an underscore, but it's removed those two columns because you can see that the default argument for remove is true. If I wanted to keep them, then I could say remove equals false, and it would keep the other ones there. So here's my eth gender. And if I want to change the separator used, like I want a space, I can use a space. Or I can do whatever I want as the separator. I think it's space. Okay, I'm just going to check that this knits now to make sure that it all, that I haven't made any errors there. Yes, that looks fine.